Okay. I think we can start. Um, Hello everyone. Thank you for coming to my talk about Jetpack Compose. I'm Lukasz, Ruka Toptal. Um, well, there's some stuff about me. Jetpack Compose, the new UI framework from Google. Who's already excited for it? Okay, cool. We'll see what Jetpack Compose is and why it's built. Jetpack Compose is the new UI framework from Google, which will allow us to build our UIs in a completely new way. Jetpack Compose changes drastically. I prepared slides yesterday, so they might be out of date already. It just can happen. So why do we need something new? First of all, the current Android UI toolkit is already over 10 years old. And it was built with constraints that were there 10 years ago, and for devices that were built 10 years ago. And most of them are not really relevant anymore. So 10 years old is an eternity in software, and more so with 10 years of backwards compatibility, which Google had to maintain, because Android devices aren't really updated that often, if ever. So another problem of the current UI toolkit is its design, where the primary way of sharing things is inheritance. And like the classic example is the button and image button, where button extends from text view because it shows a text, and image button extends from image view because it shows an image. But they're both buttons, and there's nowhere where the actual button functionality is shared, which is not good, and it actually is a problem even for new libraries like material design, where they have to copy entire blocks of code across components because they can't be shared reliably. For example, if you take a look at material design's radio button and material checkbox, they will be exactly the same, and just the names will be changed from the checkbox to radio button. State management, it is there, obviously. We need something. But over those 10 years, some new frameworks and new ideas has been presented, which work better than this simple state management that was given for us in the initial version of Android. So it would be nice to introduce it as well. API fragmentation is a problem in terms of we have tons of options to do everything. We can show an activity, a fragment, a custom view. We can share the functionality by creating a custom view or by creating an included layout. We can use data binding or not. We have 3 APIs for animations, and now motion layout comes out, so it's 4th one. And they all are supposed to fix some problems, but they all built on those 10-year-old foundations. And it kind of starts being clear that you can't really fix everything while using these old foundations. And the problem is that when we write our UI, we have to write the layout in XML, some logic in Kotlin, then some styles, also in XML, but in different file, and then probably some attributes, and then some code in fragment, or the activity. And people also try to work around this, and there are new libraries that will allow you to build the UIs from the code completely and to style the UIs from the code. But again, they all have to work with these 10 years old foundations, and it doesn't seem it's working out very well. And it's not really testable. It's quite difficult to test, and even then we have a couple of options. We can unit test, use Roboelectric, we can use Espresso, we can take screenshots, and none of this feels right. So what would be the solution? Like, what would we want from new UI toolkit? So it should be easy to update without updating system. We know it's a problem, and it will be a problem for a foreseeable future to update Android. So we want to not have to rely on users updating their phones. Smaller API surface, so we want to have less choice. We don't want to have to think about whether we want to use fragments or or custom views, or one of 5 or 10 animation APIs. It's enough that we can do everything reliably, even if it's just just one way of doing it, but if we can do it, that's fine. Clear state ownership, if we can borrow from those frameworks or ideas that appeared over the 10 years, there are some of them that work really well and they're basically proven in the wild, so why just not use them? We want to write less code overall, who doesn't? Maybe less code isn't a virtue in itself, but currently it's definitely too much code, so we definitely want to make it less. We do need compatibility with the current UI toolkit. We don't want to rewrite everything or have to wait until we write a new application to be able to use it. And we want to be able to easily test it, finally. So enter Jetpack Compose, which is unbundled from system because it is a library. We can just update it whenever a new version comes out. It does have smaller API surface. Basically, there are just a couple of core components and ideas in Jetpack Compose, but together they're powerful. The API is small, but it's very dense. You can do a lot of things with it. Clear state ownership is, of course, also there, and we'll talk about specifics later. It borrows from frameworks like React, Flutter, or Vue.js, which work. People are happy with them, so why not use them? It will be less code, most likely. We don't even know it because there's, we didn't see any actual production level application, and the APIs are not stable. But it most likely will be less code. The goal, the current idea is that it will be compatible with UI framework, and it's like a hard requirement, just because otherwise it wouldn't be really adopted well. So Google folks are really thinking about compatibility and two-ways compatibility so that we can use new Compose within XMLs and use XMLs within Compose. So we'll do it both ways. And it is also designed with testability in mind. So it is available now. It's a very early preview, alpha, pre-production, do not use in production version. And do not. Actually, someone already uses it in production, just so that it is somewhere in production. They have some dialogue or whatever. But do try it out. It's really easy to try out. And feedback is listened to. Google listens to feedback, and they engage in conversation. So you definitely want to try it out. You can use it with Android Studio 4.0, which came out on Wednesday. And there is new Compose activity template, which sets up everything for you. And you just can start playing with it. OK, so these are the basic building blocks. We'll go over them one by one. And there's like two things. One is the compiler plugin. And it's something, it's interesting because Google actually are working on the compiler plugin on the Kotlin compiler so that they can introduce plugins. So there is quite a lot of work being put into the Kotlin compiler itself by Google so that they have options to do things that wouldn't be possible otherwise. And then there is the API that we'll use, like functions, effects, and stuff. Cool, so composable. This is the core element of the composable API, and it's an annotation, just a simple annotation. But it's an annotation that's very similar to what we already have with coroutines. So if you remember coroutines, when you write a suspendable function, Kotlin compiler will do some magic with it. It will take the suspended function, and whenever you call it, it will add some parameters, and then it will intercept calls to other suspendable functions within suspendable function, add some other parameters, call it more and less. And this is exactly what happens with Compose. And this is exactly why Google is modifying the compiler to do the same thing, but without having to introduce a new keyword. And they replace the keyword with an annotation. So whenever you are interested in how composable works under the hood, keep in mind it's a very similar mechanism to suspendable function, because the compiler plugin will also add some parameters. It will also intercept methods to other composable functions. And it's very similar. And we would use it in a similar way to suspended functions. So we will annotate functions with a composable annotation. We can accept parameters and lambdas that also have this annotation. And then we can call and nest composable functions together. And the general idea is that composable framework will be aware of the structure of your composable calls, and it will be able to call some of them more than once. So for example, here, this child might, like when you're running your app, it will turn out that this child lambda is called 10 times, even though the other composable function is called just once. And this already solves us the big problem with the inheritance that we had with current UI framework. Here, because we can just accept, like pass those building blocks, we can define components that only do what they're supposed to do. And this is like a single responsibility principle in the UI. So here, a button will know how to deal with the fact that it's a button. So it will know that it needs to handle clicks. It will know how to notify someone that it has been clicked and maybe do some things like shadows. But it doesn't really need to know what's inside. We can do whatever. So the API accepts a composable function, which will tell what is inside, and we can pass everything to it. So creating something that would be either quite complex to have a button with this UI in Android is just that simple in Compose. So that's how we will build our UIs, more or less, just stacking those composable functions that do things. And the other core part of this entire thing is state management. And one of the primary ways of state management is using models. And models are special, are classes that are treated by the Compose runtimes in a special way. So in this case, we have a button which will show the counter as its text. And on click, it will increase this counter. So the important thing is here that we have this model annotation, and it will tell the runtime to note every call to this model properties. So whenever something accesses counter or any other property within a model, it will just be available to the runtime, to the Compose runtime. And Compose will see that the children, lambda, the text, that it depends on the value of counter. It is available information to the runtime because it has a model annotation, the class. So whenever the counter changes, this lambda with the text will be run again. So whenever the counter is increased, we will show the next number there. And basically, Compose will wire it up together. So whenever counter is changed, the value will update. And we'll see that in a bit kind of more clearly. But the idea is that it will just figure out automatically that something has changed, and that means something else has to be updated. And this model annotation gives us that. Another option is to have a local state, for example. So this is the same thing, but now we don't have to have a custom model class. We can just say that we have some piece of state, which we will manage in this composable function. And this already shows that the state is very explicit. Button will not have its state. Text fields, edit text, will not have their own state. Every state in the UI, we will have to know that it's there, and we have to manage it manually. So the state here is an example of, a concrete example of something called effect, which is also one of the important things in Compose. And this, the definition, executable code that runs positionally, it's just a fancy way of saying that effects are things that will be shared across composable function runs. So I said that composable functions can run more than once. So if it runs 10 times, there is some code that we don't want to run 10 times, something we want to call just once or twice. And effects allow us to step out of this composability and then go back with some value. And we will see that as well. But also, this state effect, it will likely be replaced. So the effects will stay, but the API will probably change in favor of composable functions that return a value. And so that to show you how early in the design it is, Google folks still don't know if the API will be replaced or not. They would like to, but we'll figure out if it plays out. And these effects allow us to do some things like state management. They will allow us to hook up into the composable lifecycle, because there is one, obviously. And it will allow us, the ambient thing is like an inherited widget in Flutter. So it will allow us to reach out to get things without having to pass them explicitly. And we'll see that as well. And just one thing that I wanted to mention, which is not maybe like the absolutely core API, but is kind of controversial, are modifiers. So in a pure way of making this functional UI, if you wanted to add some padding to a text, and it's like Flutter does it, for example, we would have a padding function which accepts some children and just pads them, right? And this can get cumbersome really easily when you have tons of paddings or just some things that aren't really that crucial to the UI, and you just get nested functions by a lot. So what Google decided we'll do is add modifiers, which is, so now this padding, instead of being a function, it's a modifiers, and modifiers are handled by the runtime in a special way. So it kind of breaks this pattern of composable functions, and some people don't really like it. On the other hand, it does help with readability, and it is still composable. The fact that we have this modifier doesn't mean that text knows that it has to pad itself. It is still handled very separately in a separate place. But it's controversial. And the question is, for example, will we be able to do drawing in the modifiers? We don't know yet. Live demo. I hope it, yeah, let's see. Okay. Okay, so this is the template that we get when we want to this is the template for composable application in Android Studio that I mentioned. This is just the defaults, and we can see that there are some new features in the Gradle plugin, like Compose. We just import the libraries. Sorry, actually this for Compose, and we also need to use a early access preview compiler, Kotlin compiler, just so that Google can inject this compiler plugin. Okay, so let's see. First thing that was added also on Wednesday was actually together with the Android Studio 4.0 is this at preview annotation. Before that, it was kind of annoying because every time you change something with the UI, you had to run it on the device, and it would just recompile everything and run it. So now we can have this at preview annotation, and it will render in a separate, just like XML layouts, which is pretty nice. And it shows that it's they're thinking about tooling a lot as well. And another thing that is important is this set content. Suspendable functions, if you want to call them, you need to start the coroutine somehow with some coroutine builder. And the same thing for Compose. You need to have some entry point where you can actually start writing composable functions, because writing composable function outside of composable function would be forbidden. So this function sets up the initial composable function that we can nest our app in. Okay, so let's first maybe just extract this application, the code that we have right now, to a separate function called app. And I'm going to just move it here so that it doesn't nest this much, and make it composable. And I want to show this app in the preview and not some random code, so I will know what I'm doing. And when I refresh, it still shows the same thing, which is what I'm expecting. This is kind of not really readable, I know, so I will fix it with a stack. And don't worry about it yet. It's just, I'm going to add a background. Sorry, not card. It's colored. Just a white background. And it does look more like an application. OK, so we will classically write a to-do app, because that's easy. And we already know that we will have some to-do class, so I'll just make it easier and just add one. We will have a to-dos, which will have a description, text, and an information whether it's done or not. OK, so let's start by showing the list of to-dos. Let's create some list first. To-dos. And let's have just 3, so that. And this is going to be some to-do, and it's not going to be done. And we want to, oh yeah, that's actually called app, so maybe let's move it to the app function so that we start in one place. And let's keep the material theme, and let's show the to-dos list. To-dos. So the nice thing here is that in composable functions, we can run any code we want, including loops. So we can just, for each to-do, we will render it as text. A description for now. And if I refresh, we can see that it looks a bit weird, because like all the to-dos are stuck together. And that's because we didn't tell anything about how we actually want to lay out these to-dos, right? We just say, draw a to-do, draw a to-do, draw. That doesn't make much sense. So what we want to do is we want to show them one by one in a column. So we have a column. And you can notice that I'm not really using the completion, just because if you see that I want to complete, it breaks everything. So it's really early preview. So I want to show it in a column. Let's refresh. And it's amazing. When I was playing with Compose like a week back, it was so annoying to figure out the views. Yep. So we have a list. OK. It's just to keep it clean. Let's already extract it to a to-do list function. We will want to extract functions a lot and see how easy it is with the existing tooling. We can just use all the refactorings that are for Kotlin and no XML. Stuff. OK, so now we have just a simple text. Let me see. One thing that is also important for Compose is that it will have material design components built by default. It will be a library, so it's not like Jetpack Compose will be defined by material design. But material design is being built as we speak, and not just later. So I think Compose will overtake material design components for Android pretty quickly because of how easy it is to write it. So one of the material components that we have is this list item, and the completion is weird. So if we just, and this list item is a function which will show a list item according to material design guidelines for the list item, which will have some padding and the text style and stuff. And we have this list. Cool. So another thing that is defined in material list item is a trailing icon. So something that will be shown on the right here beside the text. And it happens that there is this trailing parameter, which takes a composable lambda, which means we can put anything in it. It's not like list item says something on the right will be an icon. It says there will be something on the right, and list item knows how big it has to be, and just put anything there, and we will just size it to be appropriate. So I can choose that it's going to be a checkbox, for example. And this checkbox is going to be checked whenever to-do is done, and we will not deal with the state yet. And it complains that the string is is not good here. And that's because the list item has more than one overload, and initial one was just the accepted just text. But now that we started introducing composable lambdas, we just need to add lambdas everywhere, right? So I'm going to refresh it, and we can see that the checkbox is there, but the text isn't. Why is that? And that's because this is not a composable, like this runs in a composable function, but it's just a text. So what does it, like what compose does with that, just a value? Nothing. Why would it do anything? So what we actually need is we want to say that we want to render a text here. And this is already a big challenge, that there's no really strong typing in the composable functions. We don't know whether a composable function accepts one parameter or many, or actually it's not parameter. Like, yeah, we don't know if the composable function handles more than one child, basically. So when we change it to text, we have nice list items. OK, that is the UI. So let's maybe move to actual state management. And for that, I will have to run the emulator. I will have to run the emulator. And run the app. Oh, yeah. Cool. So the app works. That's good. But when I check it, nothing happens. And why is that? And that's exactly what I mentioned. Yeah, that's also broken sometimes. Is that we need to take ownership of the state. Checkbox will not manage state for us, because that's not the idea. So right now, we tell the checkbox specifically whether it should be checked or not. It's not initial state of the checkbox, or be checked unless someone clicks on it. No, we just have to take ownership of it. And we already have a place to save this. This state, and it's exactly the to-do model. So let's just, yeah, this is it. So that's going to be checked. So let's set is done to new check the value. Let me just rename it for clarity. It's a to-do. And right now it's a value. So let's make it a mutable property. And let's run it again. And also it's amazing because Google just added fixed the updation, like apply changes, so that whenever you add a class, it will still apply changes. So it's really quick now. OK, so now we set this is done state in the to-do, but it still doesn't work. And why is that? It's because right now, this property here and this mutable property here, they're just properties. And well, you can do whatever with properties. So we need to tell Compose to monitor changes to these properties and react to them appropriately. And that's where the model annotation comes in. So this model just tells us whenever someone checks this, then please update the composable function that contains accessor that accesses this value, and this will be this. So what's interesting here, let's see that it works. Oh, yes, it works. Nice. So, yeah. So now what happens is when I check the button, this lambda will run. It will set the property. And Jetpack Compose, because it knows that it deals with a model, it will say, OK, something has changed with this property. Where else is it accessed? It's accessed here. So it says, OK, I'm going to take the closest composable function to it and run it again. And it runs it again. So we see the new value. So it also, what Compose doesn't do, it doesn't run this function. Because it doesn't access the isDone property, so it doesn't have to. So we're fine. OK, so let's just add one more thing. Let's try see if we can add some to-dos to the list. So I'm going to have some text field and an add button, and whenever we type something, we want to add that to do. So let's create a composable function called header, just because. OK, and what I want there is I want a row of items where I will have text field on the left, and initially it will just be empty. And then I will have a button with add text on the right. And then I want to have header on above the to-do list, so I need to add another column here. And don't worry about performance, because first, it's not really performance right now anyway, so. No, but also the idea is that you don't really have to care this much about nesting composables, because you will nest them a lot, and it's the runtime responsibility to update this efficiently. So this column will probably not run as often as you actually, it will not measure as often as you think it would. OK, so let's run this. And spoiler alert, it doesn't work. Yeah, it crashes. And let's see why. So, and does it, yeah, the simulator. And the stack trace is pretty long. I don't know if you can see it. Yeah, you can. Stack trace is pretty long because we're already nesting a lot of lambdas. But so it says that there's some illegal argument exception, and that minimum width should be finite. OK, it happens in constraints, and in text field. And so after a little digging, you will know that text field, I think it tries to be as wide as possible. So we need to say that, OK, just don't go to infinity. Just take some less space. And after inspecting raw documentation, it will say to use modifier to set how the children will look like. So we should set some modifier on the text field. Basically, this is indeed the documentation, so it's not like magic. But there is no modifiers here. And that's because basically the APIs have not been updated after adding modifiers. Most of the components will have modifiers, they just don't yet. So let's work around it by having a container with this text field, and this container will have a modifier. It's called flexible, and it's more or less like this kind of says that this text field should take as much space as it can after placing all the children in the same, like button will size itself, and then text will take the rest. So let's run it, and we don't see any text view. And that's also because now we can start debugging. Debugging is pretty annoying, like the UIs, because we don't have any option to actually show layout bounds, for example. Everything here is drawn directly on the canvas. It doesn't use Android view, so we don't have actual bounds. So we just need to figure out, and I already know because that there is this main axis size here, and if we say expand, it will take as much as the parent and not as little as children. OK, and now we have this text view here, which is invisible. So let me add some padding to the text view. And I mentioned that modifiers can be nested of sort, and this is done using wraps. And I will just add a spacing of, like 12 dp. And let's run it again. And we can see something here, right? Let's type something. Will it work? No. Doesn't work because we say that the text field's value should be just, should be empty. So again, the pattern that we need to do is we need to take ownership of the state. We don't have any model here, so we need some private state. So let's say text is a state of string, and initially it's empty. So state is an effect, and this plus will go away. Don't get too attached. And again, unstable API. And we want this text value here. And now we also can finally react to value changes. And again, this is kind of weird that we need to figure out that something has changed and change it explicitly. But again, that's because text field will not manage its own state. So what we need to do is just say that the text state will be the new text value. That works. And it's nice because it fixes a lot of problems with Android where you get notified that the state has changed. And then sometimes you don't want this state to have changed. For example, if I wanted to prohibit numbers here, I can just say it filter not it is digit. And when I hope it works. I haven't tried that before, actually. So I'm typing the digits, and something breaks, but basically it doesn't type the digit, which was the point. And like in Android, you would often get that checkbox has changed, but you don't want to allow checkbox to be changed, so we need to revert this state change, and this is just something you don't want to do. Okay, I don't have much time, so that will be it with the demo. But adding the new item to the list would be more or less the same. We would have to explicitly take ownership of the state and pass it to the header to modify it, and like everything would be very explicit. And you can try out, there is this demo app built with Compose, Google sample, which has a lot more APIs that you can check out too. Okay, so let's go to the presentation. So, what challenges we have? Lack of strong typing, as I mentioned. You just accept functions and call functions, and this can pose a problem in terms of defining some behavior. For example, how would padding behave if it got two children? Like if two composable functions were emitted in a padding, should it pad both of them, just one? How should it position them? One after the other, one on top of the other, but positioning one on top of the other is already Stack's responsibility, so it's kind of tricky. We don't have references to the views, and this is where Compose took a very different road than any other similar framework. In Flutter, we have widgets, and we just can hold widgets and see and inspect them. In SwiftUI, we return views directly, and here we don't have anything. We only call functions. The functions don't return anything, and Jetpack Compose handles things internally. And this is weird. But Google folks say they are pretty confident with this decision, even though initially they were skeptical. And we'll see where it goes. Tons of work. It's like so not done. I didn't find a way to set a hint on the text field, which is kind of basic functionality, right? But it's not there yet. So don't be discouraged if something doesn't work or if something isn't there. It will be there. It's just so early preview that you can't expect anything. Compatibility is a challenge. It will be there, but the Compose and current Android views are just so different from each other that it might be an issue. We know for sure that Google will not rewrite all the components. For example, it won't rewrite WebView because it's just so much work. So we actually we'll have to use web views anyway. And if you have a library which gives you some custom views, you will want to use it even without them updating to Compose. And a lot more, just it's a so early preview. Okay, and now a couple of fun bits that I found in the source code, or primarily on Slack. One is that even in the comments in actual Compose source code, you see references to testing, which is already nice. But there's a mention of reliable screenshot tests, which is a nice idea to screenshot your tests, your views, and then when you change something, verify that the screenshot is still the same, that you haven't broken anything. And you don't really have to compare that the composable function composes exactly the same widgets. You just need to make sure that it looks the same. And the other thing about testing is that Leland is one of the main guys that works on Compose, is that testing composables should not require platform dependencies, which means we should be able to run screenshot tests and basically every test for the views without emulator or without a physical device, which is a huge win for development speed. Another interesting thing is that Jetpack Compose actually solves a lot of problems and replaces a lot of APIs that we have right now. For example, navigation can be as simple as changing some top-level state and rendering a completely different composable. So we should be able to do navigation using that and integrate with navigation component, possibly. But eventually, we should be able to build our entire UI using composable function and just say, just show an activity which will only show our composable, which would be nice. Another thing is configuration changes. If you think about it, configuration is also just a state. So if the current configuration here was annotated with @model, and whenever it would change from landscape to portrait or the other way around, or language changes, then Compose would have to figure out that something depended on that configuration, so it should recompose the views that depend on that. So essentially, we would get configuration changes for free. Another thing is that we don't actually have to have mutable properties and models. Compose works really well with observable and immutable data. And the effects API is rather, it's very flexible. So we should be able to integrate it with live data, with RX, with Flow, whatever reactive comp framework you use. And just to confirm that Jim also works at Google on then I mentioned this. I mentioned effects, and for example, ambient. And ambient is kind of used to break this pattern of passing explicit state. So we are already warned not to use it too much because we can just, stray away from what's intended way of building. So just be careful, and how to use it. Best not to at all. Obviously, that's going too far. We should probably, we have some, this was actually in the context of dependency injection, which I would say probably will be a valid usage of ambience, but just be careful with it. This is also interesting. This is part of Compose source code, and we have this iOS reference. Like on iOS, these values are ignored, and the class has some parameters. But Compose doesn't really target iOS, right? And if you look around, then this is code from Flutter source code. And you see this at immutable annotation used in Dart to mark immutable classes. And then there is this comment with immutable annotation. So they are inspired by Flutter, definitely. The same picture. So what the future holds? One, it would be nice to reduce the nesting of the composable functions. And there have been talks about pipe operator. It would be, I said pipe. It looks like pipe, but it will be just function composition. But it most likely won't be there anytime soon, because it would probably hurt Kotlin adoption quite a bit. It would be suddenly much less familiar for people. Preview, done. Done. It's available, and the slide was ready before that, so like 3 days ago, let's say, ages. Constraint layout composable, also to reduce nesting and to use something that we are familiar with, and it's quite nice. Multi-threaded layout, because now we are completely separate from the existing UI toolkit and from its limitations. And one of primary limitations of current UI toolkit is that everything has to run on the main thread, like drawing, and layout. And now we don't have those limitations. We can just kick off some threads, and Compose can layout it in a background thread, so it will be quite nice. And tons and tons and tons and tons of API changes. There are already changes, like APIs that will go away for sure, and I know nobody just got around to doing that yet. Okay, so what now? I encourage you to join Compose channel on Kotlin Slack, Kotlin Lang Slack. A lot of Googlers are there, and they're very responsive. If anyone has questions about internal design or about the future of Compose, they really engage in conversation, which is awesome. There is now official documentation that is a bit more than, you don't have to browse the source code to figure things out. There is post from intelligible. It's from the Leland Richardson, one of the main developers, and it tells about how actually Compose runs in the of the details of how Compose builds the views. And it's quite nice to understand just the basic principles. And there is a code lab now as well, so that's great. And that's it. Thank you. Yeah.